Hi everyone, welcome to Electronics Techie. So in this video, we are going to discuss about CMOS technology. So the full form of the CMOS technology is Complementary Metal Oxide Semiconductor. So before going to this video, so someone will ask about the JFET. So upcoming video is about JFET only. Sorry for the delay. So okay. So coming to this video, what is CMOS? So CMOS. So in the name itself, there will be a complementary. So the definition will explain you what is mean by complementary. Why you called as a MOS with complementary. So CMOS stands for Complementary Metal Oxide Semiconductor. So it is a technology used to build integrated circuit. So it is one of the technologies. CMOS technology is one of the thing we are going to design a circuit. Designing integrated circuits means what are the transistors are made in the within the one single chip. We call it as a integrated circuit using the pair of complementary MOSFET. Complementary MOSFET, which means we are going to use one P type, that means PMOS, and one NMOS, that means N type material. So that means NMOS. So one PMOS and one NMOS. Not only one and one P. So related to the circuit, we can design multiple complementary circuits. The basic thing we are going to use one PMOS as well as the number of PMOS what you are going to use. We are going to use that NMOS circuits. So by combining the PMOS and NMOS, we are going to get the CMOS. So that's why you are called it as a complementary. So PMOS is complement to NMOS, NMOS is complement to PMOS. That's why we call it as a complementary metal oxide semiconductor fin effect transistor. So on the same chip. So which means the single chip itself, it contains the PMOS and NMOS technology on that. So it is the extension of the MOSFET sections. So BJTs are overcome by BJT have some disadvantages that can be overcome by JFET. So in JFET also there is no controllability. Some disadvantages will be there. We discuss in upcoming video. So then it will be moved to the MOSFET. So after the MOSFET, by using this MOSFET technology, we are going to use CMOS. Means whatever the MOSFETs we have, NMOS and PMOS, that is going to be combined by getting the CMOS. So that will be our trending thing. The CMOS technology will be lot of changes in our devices. So C means complementary, M means metal, O means oxide, S means semiconductors. So coming to the symbols. So the CMOS structure is like there is a pull up and pull down circuits will be there. So in the CMOS, there is a pull up and pull down circuits there. So we are going to give the input and we are going to collect the output. So there will be a pull up network and pull down network. So pull up network contains PMOS circuits and pull down network contains NMOS circuits. So why pull up is contains PMOS, why pull down is contain NMOS? So means PMOS can on for low signals, which means 0. For 0, the PMOS is going to be on. For NMOS, we are going to give high input, means that is 1. So what will happen means the PMOS output can drive from high, means whatever the VDD we are going to connect, from high to the output voltage we are going to give it. So NMOS can decrement the value up to ground. So that's why we can use NMOS as the pull down. So PMOS, why as pull up means it can give the output up to VDD. So coming to the NMOS, it can give value up to ground. So without any deviations or fluctuations. So okay. In practical, it may be little bit, but NMOS can drain up to ground, but PMOS drain up to VDD as output. So that's why we use PMOS and NMOS. So coming to the things, gate, input terminal. So by using gate terminal only, you are going to give the input in the CMOS technology. So control the on and switch, on and off switch means by giving apply means 1 minute, I will erase all the things. So by applying the input from gate, we are going to control the CMOS technology, which is the CMOS is going to be on or off, those things. So source. So why are going to use source means supplies current carriers to the channel. So what it done means it can supply the carriers means electrons. What are in NMOS we are going to give electrons, in PMOS the holes is going to carry to form the channel. So to flow in the channel. Okay. So coming to the drain, output terminal. From drain itself we are going to collect the carriers. So collect current carriers. We are going to collect the current carries in the drain terminal. So body means substrate, sets the threshold voltage. So body is nothing but in the substrate only you are going to design the wells. In that wells you have to form the source and drains like that. So coming to the VDD, it is the supply voltage, and a ground, it will be the ground connected to the end source. So you know that the supply means what you are going to say, the VDD is going to be connected to the pull up network and the ground is going to connect to the NMOS circuit. Okay. I think up to now is it clear? If you have any doubts till now, you can comment for it. Okay. So, source, drain, gate. Source, drain, gate. So always remember the input from gate itself, the source the source of the PMOS is always connected to VDD. The source of NMOS is connected to ground. So from drain of the PMOS and NMOS, we are going to collect the output. Okay. So coming to the CMOS network. So have pull up and pull down network. So coming to the detailed explanation of the pull up and pull down network is, so pull up network. So pull up network, what it contains? It made up of PMOS transistors. So what is the P-type material is going to be designed the semiconductor. So that PMOS transistors is going to be using this pull up network. So connected between the VDD and output. So whatever the PMOS is going, the PMOS symbol is like this. So whatever the drain is connected to VDD from source is connected to VDD. From drain, we are going to collect the output of the PMOS. So pulls output to the logic high. So what will happen means, when we apply the input 0, it is going to be means not only 0, 0 or low signal. For low signals, the PMOS is going to be activate. So whatever the VDD, it can be pull up to the VDD means logic high. So without any fluctuations means if NMOS can be used in this place, it can't drive up to VDD. It can't pull the output up to VDD. Some disadvantage will be there. So that's why we prefer PMOS as the pull-up network. So conduct when input is low. So what will happen? So when the input is low, the output is going to be means the PMOS is going to be on. The PMOS can get the output when it is low. So turns off when NMOS is on. So always remember, if PMOS is on, NMOS is going to be off. If NMOS is on, the PMOS is going to be off. It is the both are in the complementary. That's why we call it as a complementary network. Okay. So coming to the pull down network, we know the pull down network is designed with NMOS. The basic difference is, in the PMOS we have observed that bubble. In the NMOS we didn't observe any bubble. Okay. So made up in the gate terminal. Okay. Made up of NMOS transistors, whereas pull up is made up of with PMOS. The complementary here, the pull down is made up of with NMOS. So connected between the output and ground. So what will happen? So these NMOS is going to be connect output and the ground. So in between the output and ground, your NMOS is going to be connect. So from drain, you are going to collect the output, from source is connected to ground. Pulls output to logic 0. So whatever the ground value, so the output value is going to be pull up to 0 value. So means low value. Okay. So conduct when input is high. Whenever this NMOS is going to be turned on when the input is high or logic 1, then our NMOS is going to be turn on and get the output as you want. Okay. So turns off when PMOS is on. I already say when PMOS is on, NMOS is going to be off. If NMOS is going to be off, PMOS is going to be on. So vice versa. So means NMOS on means PMOS is going to be off. Otherwise, if NMOS is going to be off, our PMOS is going to be on. Like that, vice versa is going to be same. So coming to the key features of the CMOS technology. So what are the things, what are the important notes we are going to discuss about the CMOS is, this is a low power consumption. So coming to the MOSFET, BJT, JFET, all the things, CMOS can contain the low power consumption. What is the input signal you are going to give in? So for switching or amplifying all the things, the CMOS technology is going to be consumed very less power. For low power applications, you are going to use this CMOS technology. So draws power only while during transitions, ideal for battery powered and mobile devices. Means whenever the device is going to be work, then only the power is going to be consumed. Whenever it is in the idle state without any working, it can't consume any power. So that's why it consumes very less power in our mobile devices. So coming to our mobiles, the battery. Everyone think our mobile battery is going to be large. So while traveling, while moving anything, anywhere, while going to office, so everyone want to charge once at a day. Someone if they don't watch much more of mobile, they want 2 days. The charge will going to be long lasting. So that's why. So everyone want the mobile going to be charged very slow, means very less times, and give the charge for more time. So for that less power consumptions, we are going to use the CMOS technology. So coming to the high noise margin. So excellent immunity to voice noise, voltage noise and interference. Logic levels are clearly defined. So what will happen is high noise margin. It can't fluctuate with the simple noise. So there is a while there is a signal is going to be passed, so there is a lot of noise signals will going to be passed within with the input signal itself. So what will happen if the circuit is going to be activated for the low noise signals also? For every noise signal, it is going to be activated and fluctuations will become, the result will be undesirable what we want. So for that one, the CMOS technology is the best. So it has high noise margin. It can't fluctuate for easy and low noise signals. Okay. So coming to the high speed operations. So it will be going to be work fast, very quickly. If you want to done any operation quickly here. So if you want to open the app, so every person will think we are going to open the app very quickly within the seconds, within your eyes blink, within the million mini seconds. We are going to operate whatever you want. So that fastness is going to be given by the CMOS. So coming to the mini integration density. So means million to billions of transistors fit in a single chip. By using these CMOS technology, the size will be more compatible. Very large and billions of transistors going to be integrated in the single chip itself. Scalability. So according to the Moore's law, we know the Moore's law. Every 2 years or 2 years or 18 months, the number of transistors on a single chip is going to be double every 2 years or 18 months. We all know about the Moore's law. That CMOS can satisfy this technology, this Moore's law also. That's why we call it as one of the major technology in our daily life. So complementary actions. Here PMOS and NMOS both are the complementary things. If one is on, another will be going to be off. So there is no direct path between VDD and ground. So if PMOS is going to be on, NMOS is off. So the connection is mismatched. So like that, there is no direct connection. So the power is going to be consumed very less. That's done. So the remaining things are low heat dissipation. So while doing any work, it can release less amount of heat. Okay, rail to rail output. So output swings of the ground and VDD can be maximized. The means it can get means the logic 1 and the logic 0 will be the strong ones. We get the output as very strong without any deviations. So high input impedance. So high input impedance, which means the voltage which are going to be controlled by the impedance. So it's like the resistance only, but the impedance having the AC signals along with the DC signals also. So the CMOS technology contain the high input impedance. Okay. So the process capability, which means PMOS and NMOS fabricated on the same substrate. Means what will happen? PMOS and NMOS are the opposite one, but although we are going to fabricate all the things in a single chip, so that's why it will be more compatible. Okay, so these are the main key features of the CMOS technology. Everyone have to know these key concepts of the CMOS technology. Okay, CMOS is a very important topic or any basic subject for the physical design engineer. So okay, not only physical design engineer, as electronic students, you have to know all of these things. So okay, so coming to the next thing. So up to now we discuss about the key features, all the things. What is the pull up, how the means how the CMOS is going to be work. What is the structure? What is the things we are going to discuss till now. So in CMOS technology, what are the requirements? So every person has some requirements, but common requirements of every person is like the CMOS technology can satisfy all these things. PPA. We call it as a PPA. So what it means PPA? P means performance. Simply you have to remember like this. So PPA means P means performance. Another P means power. A means area. So coming to the CMOS, it has a high performance. So this is the requirements of the most of the things. It can satisfied by the CMOS. High performance, low performance. So means low power consumption. So it can consume low power dissipation. So okay, it consumes less power only. Area. So it has low area. So means it can contain only small amount of area. You can integrate large number of transistors in a single chip. So these are the requirements. Okay. So coming to the things, the network, how you are going to design means. So we know that the pull up and pull down network. So two things will be there. So how is the configuration of this pull up and pull down? So let's discuss about the configuration of pull up network. PUN means pull up network and pull down network. I use shortcuts. If you didn't understand, once rewatch this. PUN means pull up network. PDN means pull down network. Okay. So pull up network consists of PMOS. So PMOS transistor is going to be contained by the pull-up network. So for end operations, so if the equation is like A dot B, so in between the A and B, you have end operation. For that end operations, the PMOSs are going to be connected in parallel. If the P means if the equation or operation in the OR means the operation in between these OR operation. So for that one, the PMOS is going to be connected in series. So all about that PMOS and NMOS are both are complementary. So pull down network is complementary to the PMOS. So end operation, for end operation, the NMOS will be the series. For OR operation, the NMOS is going to be parallel. Okay. So coming to the circuits, now circuit means coming to the circuit design. So let's see NAND gate. The simple, so first we have, before NAND, go to the NOT. So simple inverter will be the basic CMOS technology you can understand. So one PMOS pull-up network and one NMOS will in the pull-down network. So input going to be applied to the gate terminals, and who knows from drain terminals you are going to collect the outputs. The source of the, so gates are connected to the input. The source of NMOS is going to be connected to the ground. So this is the NMOS. This is going to be the PMOS. Source of the PMOS is going to be connected to the VDD. So this is the simple basic inverter. So coming to the operation, so while the input is 0, so if your input is 0, your PMOS is going to be on. So the PMOS is going to be on, our NMOS is going to be off. So what will happen if it is on? So the VDD is going to be connect output. Coming to the output. So VDD is nothing but logic 1. So the output we get is logic 1. So if the input is 1, for input 1, the PMOS is going to be off, our NMOS is going to be on. So then what will happen? So in real time, we are using some capacitors here. So the VDD is going to be charged this capacitor. When the input is going to be 1, that VDD is going to be discharged through ground. So our VDD is going to be discharged through NMOS and our output is going to be low. That means 0. This, like this, the inverter is going to be work. So coming to the next thing, NAND operation. So for NAND gate, so we know the operation is A dot B whole bar. So one thing you remember, so it is a CMOS technology. So means this is the complementary thing. So by default we get the complementary output. So for suppose if you give A as the input, we get A bar as the output. If you give A plus B as the input, we get A plus B bar as the output. If you give A dot B as the input, we get A B whole bar. Because it will be the complementary. The input is going to be complementary to the output. So that's why when you are going to design a NAND gate, A dot B bar, then what you are going to do, you just design the A dot B only. Then automatically you get that complementary output of the bar. So if you have some doubt, if there is no bar, A dot B only like this, what will happen means you have to include the bars. So like that you have to include the bars. What are the two bars you have to include? For why we cancel B, then you again get the same thing. So A dot B double bar you have to add. For this operation I am explaining. So one bar is same as this. Another bar is going to be applied to the equation. De Morgan's law. You hear that A bar plus B bar. So now design the circuits for A plus B bar whole bar. So you already get this bar for output. So now simply design for this A bar plus B bar. So like that we are going to design. So let's see some examples, then you understand clearly. So first simple NAND game. So A bar dot B bar, we already get the complement for the output. So that's why I designed for A dot B. So see, you know that the for end operation, PMOS is going to be parallel. For end operation, I am saying NMOS is going to be series. Yes, right. Okay. So first everyone do some common mistake. They start with PMOS. So there may be little clumsy. So the simple one we have to follow is, so first design the NMOS. So means pull down network is going to be designed. It will be simple. So series means A and B are going to be series. So see, is going to be series. So the ground and there will be a output here. So coming to the pull up, A, B. So NMOS is always complementary to the PMOS. So if there is in series, sorry, I will connect wrong. 1 minute, I will erase. Sorry, NAND gate. I am saying A dot B whole bar. So for end operation, pull up network, that means PMOS, are in parallel. Pull down network, that means NMOS, are in series. Okay. So coming to the pull down network, we have to try. First try the pull down network, means it is very easy to design. First you follow the pull down network. So then coming to the pull up, it is going to be. So it is connected to ground and there is the input C and B. So the drain is going to be connected here. So this is our output. Okay. So our what are the pull down network is completed. So move into the pull up network. So if it is in series, the PMOS is compulsory in the complementary way. That means it will be in the parallel. So coming to the pull up network, we are going to connect it in parallel. Okay. Like this. A and then B. If you don't like that, sorry, remove this thing. Don't give like that. So by connecting these two and collect the output at the drain terminals. Okay. So we know that the source of the PMOS is connected to VDD. So A means B means both A and these are same only, A only. So what I think it will be clumsy. That's why I represent with the alphabets. So the two inputs of the PMOS and NMOS is going to be same. So like this AND operation is going to be connected. So now let's try another thing. So without any complement. So for example, for I want to design for OR operation, it will be the A plus B. So if you directly design this A plus B, we get the output as complement, means A plus B bar. So it will be the wrong output. So what you are going to do, you have to apply the double complement for the thing. So you have to apply itself to the double complement. So one complement for the output and another complement for the equation. So one complement is same for the output. So apply the second inside this complement. So what will happen is A bar dot B bar. So which means what will happen? De Morgan's law is going to be applied here. So again there is a AND operation. So pull down network is going to be series. There is a bubble, okay. VDD output. So A bar will be the, B bar will be the inputs, okay. Not A bar, B bar. So like that we are going to design. So see another complementary circuit design. How it means. Okay, let's move some logic XOR gate. So now we all know about the XOR gate operation. A XOR B, if you extend this, A bar B plus A B bar. So you can't do directly because there is no bar. So if you do directly means you get the complete bar. So it will be wrong. So that's why you have to apply the double complement for it. So A bar plus B, A bar, whole bar, whole bar. So one is for output and another for the equation. Okay, now simplify the equation. So A bar dot B bar dot A B bar bar means we apply the De Morgan's law here. So again apply the De Morgan's law here. So A bar bar plus B bar dot A bar plus B bar. Okay. So what will happen? This bar cancel, this bar cancel. So A plus B bar, A bar plus B. So okay, this is the thing. So now let's design by using this equation. So I only represent this equation only. I will remove all the things. Okay. So what is the final equation we get? Complete bar for the output. A plus B bar and A bar plus B. So we all know for PMOS, AND operation is parallel, OR operation is series. Coming to the NMOS, AND operation is series, OR operation is going to be parallel. Okay, so now let's go and design by using pull down network first. So see, A plus B bar. So A and B both are in OR operation, which are going to be connected parallel. So first I connected parallel. So one circuit is complete. Pull down network. A and B bar. So now what will happen? Then A bar plus B. Another OR operation. OR operation means again parallel circuit. Sorry, the diagram is little bit different, but try to understand. So A bar B will be the inputs. So let's see, there will be the end operation between these two circuits. So what will happen? The both are in the series. So let's connect like this. So this will be the ground. Pull up network is going to be connected according to this. So pull down is completed. We take output from the drain terminal. Okay. So now let's see pull up network. So pull up network, if you can't, again we are seeing this end operation or operation is some time taking process. The simple thing is, see here the both are will be in parallel here. Here that both will be connected in series. Okay. What A bar B will connected in series. Here A B bar in parallel, so connected in series. A B. Again these circuit, the first circuit and the second circuit are in the parallel. Okay, so that's why connected here series means series. In pull down network, the first circuit and second circuit in series. See here. So now connected those in the parallel. So the output is connected from the drain and then source is connected to VDD. So like that, we are going to design this XOR operation. Okay. So this is the thing how we are going to design the CMOS technology by using the PMOS and NMOS transistors. Okay, I think everyone will clear these equations. If you didn't get any bar in the given question, you have to include the double bar and try to solve the equation for one complement and one complement for the output. I think everything will be the clear. So I hope this will be the useful for everything. My small suggestion is everything is try to do some more problems on this CMOS. So not only gates, we have some problematic also. In some exams, we have directly A, B, C bar plus A, B, C, A bar C plus A, B, C. So they give whatever they want. So try to solve everything. So if I think one of the thing means it is like comedy. So okay, I think one of the thing it's okay clumsy. So what I'm saying is in everywhere they only give some basic knowledge only. So the thing you have to learn from that basic only. It's your responsibility. You are the student. You are the thing. You are the person. As a person, as a human, you are the learner. Means how old are you? How big are you? You have to learn yourself for your time, means your growth, your knowledge, your improvement, your career, your success. You have to learn yourself. No one will say, learn something, learn something, learn something. Okay. So you are in the place, you have to learn yourself. Everyone says study, okay, learn, try to focus. Those are the words. But the real thing is come when you focus on your own mind. So means if everyone will say focus, 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 but it not come from the something, someone will say some words. But the thing is come when you try to focus on those things. So here I will say not NAND or XOR. So don't stop from these four only. Try to do some problems. Search for the things in your AI tools. Nowadays the technology is going to be trend so much. Not only here in YouTube, in institutes, in everywhere, in your colleges. No one will give 100% knowledge. They in some places they give 40%. In some places they give 70%. Not 100%. The remaining 30 or 60% is in your hands. You are the person who have take responsibility to learn something creativity and new. So every person have their own talent. Okay, so not everyone has weak. Someone has some knowledge, someone has some interest, some passion. So no one will decide you, no one will care you, no one will think what you are. So you are the person, you have to think who are you, what you have to do, what is your passion, what is your strength, what is your weakness, how I going to overcome those things. There is a lot of things to distract you. Means there is a phone, there is a technology, there is a screens, mobile, every whatever the thing, everything will be there. So the thing is, when you get the mindset of learning the things, then the real thing is coming to the picture. So okay, I hope the video is useful. Why I'm this using these things means, so everyone see the video and understand something from that video and close the video and something is completed. But what I want to say is, so after the completion of video also, we have to try something other examples what I say. Not only me, if you watch another videos also, try to do some problems on that particular concept. Then only you can remember that concept for a long time. So no one will say all these things or try to do some examples like that. So it will be the conscious thing you have. Means you only know the things. So no one will try to say always. Okay, I hope these video may be helpful. If you want any other concepts related to the electronics, you can comment for it. If there is a short information, I make it as a short. And coming to the lengthy information, I will make as a video. So someone will ask JFED, definitely I will make that video for the next concept. Okay, thanks for watching and thanks for keep supporting me like that. And then bye.